Qualitative identification of unknown solutions. In this experiment, we're going to be identifying a set of unknown solutions using qualitative observations. That means that we're not taking any actual measurements, or we're not taking measurements of numbers, which is a quantitative measurement. So qualitative identification, we're going to be mixing solutions that we know what they are, and based on the observations for those solutions, we're going to use those observations to identify the unknown solutions. The types of observations that you have to be looking for during these experiments are the ones that I have listed here from 1 through 4. So you have formation of a precipitate, and a precipitate is a solid compound. So you're mixing aqueous solutions. When you have your aqueous solutions, those solutions are prepared by dissolving a compound or a substance in water as a solvent. So you have your aqueous solution. So I have in number 1, formation of a precipitate. I have an example. You're mixing 2 aqueous solutions, AB and CD. Now those aqueous solutions are going to give you ions in solution, and then with your ionic exchange, which is something that you will see in the next video, you will get your products AD and BC. BC, I'm identifying that one as a solid. When you get a solid as a product of a reaction, that solid is a precipitate, and that's a precipitation reaction. So that's one of the things that you have to be looking for in formation of a solid. You can also check for any color changes. When you're looking for color changes, I wrote here an example, like it's not that you have a solution that is, let's say, dark orange, and you're adding water and now it looks light orange. That's an example of a dilution. So you're changing the concentration but not the substance that you have. That's not an example of a chemical change happening. Number 3 is formation of a gas. That's easy for you to identify because you will see like bubbles forming in your solution. That's the gas that is being formed, that is escaping the solution. And number 4, also temperature change. Temperature change is a type of observation that is not exclusive for chemical changes. You can have physical changes that they involve energy transfer, which is what happens when you have a temperature change. So I'm writing here an example for ammonium chloride. Ammonium chloride is a solid at room temperature. When you put ammonium chloride in water, it will dissolve because it's soluble in water. It will dissolve to form the ions. But that process for your ammonium chloride to dissolve in the water, it's an endothermic process. It means that it absorbs heat in order for that ionic bond to break and give you the ions in solution. So that's an example of a physical process that involves absorption of energy, or that it's endothermic. Like the one that I have listed here on the left side of the diagram when you have reactions. So your chemical reactions, they can be endothermic on the left side or exothermic on the right side. For endothermic, you will feel the container of your chemical reaction, or where the reaction is happening, it will get cooler. The temperature will decrease, but because that reaction is absorbing heat, so it will feel cooler. Now on the right side for your exothermic, that's the opposite. For exothermic reactions, the container for your reaction, it will feel hotter. The temperature will increase because that reaction will be releasing the heat, and that amount of heat is the amount of heat that you feel that it's increasing the temperature of your container. So those are the 4 types of observations that you're going to be recording for all of the reactions that you're doing in this experiment. So for your procedure, you have clean 7 test tubes, soap and water. You don't have to dry them. You just make sure that they're clean. Label them and then in each test tube you're going to put one of these specific solutions that you have listed here from 1 through 7. Silver nitrate goes in the first one, so the amount that you need to put, you don't have to actually measure. I will show you in test tube, depending the size of the test tube, I will approximate an amount. If you want to measure like 2 milliliters, you can measure 2 milliliters of water and then use that test tube as an example to put all the other amounts. So in the first test tube, you're going to put the silver nitrate. In the second test tube, hydrochloric acid. In the third test tube, you're going to put sulfuric acid. Then you have barium chloride, sodium hydroxide. Then you have sodium carbonate, and the last one, potassium iodide. So 7 test tubes with 7 different solutions. You have to make sure that you don't mix the droppers in each of the bottles. You don't want to have a chemical reaction happening in the dropper for a specific solution. So you have your 7 test tubes. Then we're going to prepare the spot plate. So we're going to be using 3 drops. 3 drops for everything. 3 drops for the solution that we're adding in the spot plate. 3 drops for the solution that we're mixing with what you have. So I'm using 8 spots for the first one. So you see how I have number 1 inside of the spot plate. So you're adding 3 drops of number 1 in each one of those spots. You have 8 of them. So 3 drops of number 1, which is your silver nitrate, 3 drops, 3 drops, 3 drops in all of these ones. Okay? And we're using all of them. The first 2 spots are just for you to check if that solution for silver nitrate is acidic or basic. We're going to do that just using litmus paper. So you have 2 types. We're going to be using 2 types of litmus paper, the red one and the blue one. Your red litmus paper, if it changes to blue, okay, it's red originally, you touch your solution with a corner of your litmus paper, and if it changes to blue, that indicates that that substance is a base. If the blue litmus paper, if you touch your blue litmus paper, you touch your solution with a blue litmus paper and it changes to red, then that indicates that that substance is acidic or an acid. So that's what you're doing in the first 2 spots. You have 1 for the red, 1 for the blue litmus paper. Now in the third spot, you have, remember, we're using solution number 1 in all 8 spots. In the third one, you're adding 3 drops of your solution number 2. So now we're mixing them here in your spot plate. So you have silver nitrate, we're going to add, you see I'm writing in blue what you're adding. So you're adding 3 drops of number 2, which is hydrochloric acid, and you're going to record any observations. If it changes color, if you see gas formation, anything like that, you're going to write down in your book. There's a table in page 133 where you can find the specific spot for your mixture, silver nitrate with hydrochloric acid. So in that spot, you can be writing down your observations. Then in the next spot, you have, remember, your 3 drops of your silver nitrate are here on the spot. And now you're adding 3 drops of sulfuric acid. Then on the bottom part, I'm looking now at this one right here, the 5th spot, you're adding 3 drops of number 4, which is barium chloride. Next, we're adding 3 drops of number 5, which is sodium hydroxide. Then we're adding 3 drops of number 6, which is sodium carbonate. And then the last one, we're adding 3 drops of number 7, which is the potassium iodide. So you're recording all of your observations. You can do one at a time and write it down, or you can mix everything and then make sure that you copy everything in your lab manual. So you're copying observation, your color changes, formation of a gas, formation of a precipitate, temperature change. When you're done with this one, look, this is giving you all of the results for your solution number 1 mixed with everything else. So when you're done with this, make sure that you have a beaker. It can be like a 400 milliliters beaker. Just transfer all of your solutions from the spot plate into that beaker, rinse it with water, and now we can prepare the spot plate for the next one. So you're preparing the spot plate in a very similar way. So now I'm just adding 3 drops of number 2, and you don't need now 8 spots because you already have your combination of number 1 and number 2. So you see, every time that we repeat this, it will be 1 less spot. So 3 drops of number 2 in the spot plate, and then first 2 again is for the litmus paper, and then the third one you're going to mix number 3, 3 drops of number 3 with number 2 that you already have in the spot plate. Then the next one is 3 drops of number 4, and you will do with 5, 6, and 7. So now you have everything for your reactant number 2 mixed with everything from 3 all the way to 7. And in the previous one you have your combination for 1 and 2. That's why we're not repeating that one in here again. Again, you're done with your spot plate and your reactant number 2. So now put all of your waste in your beaker for waste in your bench. Rinse it with water, distilled water, you can use a little bit, and then we're going to prepare the spot plate with number 3. So now you don't have 7 spots, now we're down to 6 of them. So you're in reactant number 3, that's the one that you're adding in your spot plate. 3 drops in all of the spots that I have labeled here. First 2 for the litmus paper, and then you're going to add number 4, 3 drops of number 4, 3 drops of number 5, so individually, okay? And then 3 drops of number 6, 3 drops of number 7. And now you have your number 3, that reactant with everything from 4 all the way to 7. You already have 1 and 3, you already have 2 and 3. Copy all of your observations in your La Mano, and then we move to number 4. Which is repeating the same thing again. So you're preparing your spot plate in the same way. Remember to clean everything out of your spot plate, rinse it with water, and now you can add 3 drops of number 4. And now we are down to 5 spots. So 3 drops of number 4 in 5 spots. First 2 for the litmus paper, and then you're adding number 5, 3 drops of 5, 3 drops of 6, 3 drops of 7. Copy all of your observations, put your solutions in the waste container, rinse with water, and now we're moving to reactant number 5. For reactant number 5, you just need 4 spots. So 3 drops of number 5 in the first 4 spots. First 2 for the litmus paper, and then you're mixing 5 with 6, 3 drops of 6 that you're adding, 3 drops of 7 that you're adding. You already have 1 with 5, 2 with 5, 3 with 5, 4 with 5. So you just need 6 and 7. So copy all of your observations, transfer all of your solutions into the into your own waste container in your bench, rinse it with water, and now we're preparing the last one. So for the last one, we're using number 6. So for number 6, you just need 3 spots with 3 drops of number 6. First 2 is for the litmus paper, and then the last one is for your mixture of 6 and 7. You already have 1 with 6, 2 with 6, 3 with 6, 4 with 6, 5 with 6. The only one that is missing is 6 with 7, which is the third one that you have here. Now number 7, your reactant number 7, you already have that one mixed with everything. But for number 7, the only thing that is missing is to check the litmus paper. So that's why I'm doing all of that in the same one. You have 3 spots with number 6. And then prepare 2 spots down here with number 7, 3 drops of number 7 in each one, and check the litmus paper. Again, collect all of your waste in the waste container. Make sure that you write down all of your observations. And now we're going to prepare the spot plates with the unknown. You're going to be given a set of unknowns, and your unknowns are labeled A, B, C, and D. So we're doing the same approach, but using your unknown solution. So I have my spot plate and I'm starting with unknown A. So for your unknown A, I have five spots, and that's 3 drops of A in those 5 spots. And now we're going to check the litmus paper for the first 2 spots. We're going to add 3 drops of B in the 3rd spot, 3 drops of C in the 4th one, and then 3 drops of D in the last one. Make sure that you copy all of your observations for the unknowns. Remember, you're going to find out specifically what is A, what is B, what is C, and what is D. So to find out what do you have, you're looking at your 7 initial solutions. Okay, you have them labeled 1 through 7. So you're comparing your observations from the known solutions with these ones here to actually say, okay, I think A is silver nitrate, B is hydrochloric acid, C is sodium carbonate. So when you're done with your unknown A, transfer everything into your waste container, rinse the spot plate, and now we're going to move to your unknown B. For your unknown B, you see how the number of spots is decreasing. You need just 4 spots. 3 drops of B, 3 drops of B, 3 drops of B, and 3 drops of B. And now what we're adding, the first 2 is for your litmus paper. In the 3rd one, you're adding 3 drops of C. In the last one, you're adding 3 drops of your unknown D. Copy all of your observations. In your notebook, you can transfer everything to the waste container, and we're going to do the. So for the last spot plate, you have your unknown C. So we have unknown C 3 drops in the first one, in the second one, and in the 3rd spot. Okay, so 3 drops. The first 2 is for your litmus paper. The 3rd one, you need to add 3 drops of D with that one. Remember, you already have A with C, B with C. So that you're only missing C with D, which is the last unknown. Now you have all of your mixture, but we're missing the litmus paper for D. So put 3 drops of D in 2 of the spots in your spot plate, and then check with your litmus paper if your unknown D is an acid or a base. So this is the last one that you have to prepare. Transfer everything into the waste container, rinse the spot plate with water. You have all of your observations, your known solutions 1 through 7, and all of the spot plates that you prepare with your known solutions. You need to copy your observations in the table that you have in page 133. And then for your unknown solutions, you have a similar smaller table in page 134. Okay? And in that table, you're going to copy your observations. Clean everything. Now you can transfer the waste that you have in your beaker into the waste container. Okay? And clean your beaker with soap and water, and you can return everything to the original location.